Hey guys, so today we're going to break down things that are in the universe. It's important to know the different types of galaxies and the different types of stars and what happens during their life cycle. So we've already talked a little bit about galaxies in your packet. There are three main types of galaxies, and a galaxy is a cluster of stars, gas, and dust that's held together by our old friend gravity. The three main types of galaxies that you need to know about are elliptical, spiral, and irregular. And they are exactly what their name sounds like, so it should be not too hard for you to remember. An irregular galaxy does not have a definable regular shape, and that's why we call them irregular galaxies. They have mostly young stars with a lot of dust and gas in between them. An elliptical galaxy looks like a flattened ball. It's an elliptical shape. Earth's orbit around the sun is also elliptical or oval shaped. And you can see it almost looks like somebody took the sides and smushed it together. These galaxies have billions of stars, but very little gas and dust between them. Because of that, they don't really have the ability to form new stars, and so these elliptical galaxies contain mostly old stars. Now, a spiral galaxy is a flat, rotating disk in a central concentration known as the bulge. And then they have this halo around the outside. This is probably the more typical picture that you're familiar with. These galaxies have kind of middle-aged stars. They don't have a lot of gas as much as the irregular galaxies, but they have more than the elliptical. Our Milky Way is a spiral galaxy. It's what we call a barge spiral because out on this halo they have these arms. Almost kind of reminds me of a starfish or one of those pinwheels if you ever had one of those when you were a kid. And where our solar system is, a lot of people tend to think that we must be at the center of the galaxy, but actually we are out here on the edge of one of these arms. And that's an important detail to know for your test. Now, nebulas, there are two different types. There's one where a star begins and a stellar nebula. You can think of them as a stellar nursery. And then there's a planetary nebula, which is when a star runs out of fuel. So there's two different nebulas. You need to make sure you understand the difference between them. Stars begin in a stellar nebula. They contain hydrogen gas, and as that hydrogen gas burns, it forms helium through a process known as nuclear fusion. Stars form when gravity in that nebula starts to pull together gas and dust. So in a nebula, you start to get all of this coming together. Stars release enormous amounts of energy, and that is what causes the star to become very hot and glow. There are many different types of stars. They vary in mass, size, and temperature, but the common thing that they all have is they are all held together by gravity. A small amount of volume is what a star is. A small amount of space, but a very large amount of gas. A stellar nebula is a large amount of gas and dust spread out in a huge volume. So stellar nebulas is where stars begin. They have these large areas of gas and dust, and in there is where a star will begin. Over time, what starts to happen as that gas and dust starts to get closer to each other, gravity starts to pull it together. And that contracting cloud, as those particles get closer together, When you get to have enough of it, then that's what we call a protostar. Over time, if you get enough of that material together, it becomes hot enough that nuclear fusion begins. Now, that doesn't always happen. Sometimes a protostar is as far as it gets. It might spend millions of years as a protostar before nuclear fusion begins, or it might not ever happen at all. If nuclear fusion does begin and it becomes a star, before they can tell how old it is or classify it, they have to first determine its mass. Stars that are like our sun are what we call medium mass stars, and they live for about 10 billion years. They're what we call main sequence stars. Stars with more mass have shorter lives. They burn through their fuel faster. Smaller stars use up their fuel more slowly, so they may live as long as 200 billion years. All right, so stars form in a stellar nebula. It's gravity pulling together a collapsing cloud of gas and dust. That's what we call a protostar. If it gets hot enough, then the rest of it depends on the mass of the star. When the star runs out of fuel, then depending on how big it is, depending on what the mass was, will determine whether it becomes a white dwarf or a neutron star or even a black hole. The main sequence stars are smaller and medium-sized stars. That's where a lot of stars spend the majority of their lifetime. When they start to run out of fuel, they become a red giant. And what happens is, as they run out of fuel, of course, then they start to cool. When anything cools, it expands. Think about what happens when you put a bottle of water in the freezer. As it cools, it starts to expand. So this star that is running out of fuel, these outer layers start to expand, and over time what happens is they sort of just drift off into space. What's left behind is this blue-white hot core called a white dwarf. When there's no more energy and the white dwarf has cooled, it becomes a black dwarf. And it's basically a burnt out piece of charcoal that just kind of floats around space. The more massive stars, when they start to run out of fuel, we refer to them as a red supergiant. So you can remember the massive star, a supergiant, becomes a red supergiant. Instead of just sort of their outer layers drifting off, they explode. And that is what we call a supernova. So the super stars become red supergiants, and then they become a supernova. So they're just as quick as their life is, then their life ends in this big explosion also. After the supernova, some of the material is left behind, and that may become part of a planetary nebula. What's left of the core compresses and forms a neutron star. These neutron stars are even smaller and more dense than white dwarfs. The really massive stars do something a little bit more different. They form black holes. And we're talking about stars that may have more than 40 times the mass of our sun. Even after they go supernova, they might have more than 5 times the mass of the sun left. The gravity that this mass has is so strong that the gas is pulled inward, packing it into a smaller and smaller space. So these really huge stars, after they go supernova, they become black holes. And that is your life cycle of the stars. Make sure you get your notes done, fill out your graphic organizer. Just remember the really super big stars have a really super big ending to their life also. Thanks, guys.